ask Paul and Karin to begin.
Yes.
You're on.
Okay.
You're on.
Well, good morning. Thanks for having us back. I think some of you can remember when Karin is a little younger. She's now 14 and a student at the Bradenton Christian School and a member of the National Junior Honor Society. And several years ago, she won a first prize in the science contest. So it's wonderful to have a granddaughter that knows so much science. I had 5 daughters and none of them ended up scientists, including, but at least they love science. And that's, we're thankful for her mother, Emily, who's here today, who's encouraged Karin's interest in science. So our topic today is a new creation story, verified by diet and scientific data. It all started with light. In the beginning, there was light, and for scientists, light is electromagnetic energy. It expanded, and in 13.8 billion years, we had humans. So our topic is from Big Bang hydrogen to humans. Next. In the beginning was the Word, or Logos, and the Word was God and was with God. The logical plan, now that's Logos in the original Greek from which we get the word logic, or the logical plan or emergent organizing principle is encoded in natural laws. And John 1:5 continues, light shines in the darkness. Next. So we have our symbol with a very bright flame here, our symbol of light. Next. So in 1927, the Belgian priest Georges Lemaitre, based on inspired by Einstein's general theory of relativity, predicted that hot light energy exploded in a Big Bang to form our universe. As it expanded and cooled, hydrogen atoms condensed like water droplets. And you can see, according to Einstein's famous law, energy is equal to mass times the square of the velocity of light. And I just wanted to light up our symbol here. The first time I came to this fellowship, I noted this symbol, E equals MC squared. I figured I'd come to the right place because you honor science among all the other religious symbols. So this is very much a part of modern cosmology, that basically that hot light energy was transformed into mass, and that mass was it turned out mostly hydrogen. So we'll show how in 13.8 billion years, hydrogen has been transformed into humans. Next.
So here we see the hydrogen atom, and in the hydrogen atom, it contains 1 proton and 1 electron. And the proton has a positive charge and the electron has a negative charge. And these are opposites, so they attract. And the atom is held together by the attraction of the positive and the negative. And hydrogen is also the most abundant element in the whole universe.
Next, we'll see how this played out in time. It all started with a hot Big Bang at the beginning of time and went forward. The heat is this Big Bang exploded. This electron exploded in the vertical dimension. The expansion of space is in the vertical dimension. So the universe, by the way, it expanded very rapidly to start with, and now it's still expanding. The universe is still expanding. This is our present time. This is today, 13.8 billion years later. Now there's some color coding here. White is very hot, and then yellow is cooler, and red is cooler still. And finally, after 300,000 years, it was cool enough for hydrogen atoms, shown here, to condense out, just like hot steam when it cools, when it lands on a cool plate, or actually the top of the cover of your cooking dish. You'll see these condensation of drops of water. Similarly, the hydrogen, the energy in the hot Big Bang was condensed into hydrogen atoms in 300,000 years. And then in time, gravity pulled these hydrogen together to hydrogen pulled the was pulled together by gravity into stars, and which also formed the galaxies. Next. Here's that symbol of the hydrogen atom right here. And then the Earth came into being about 10.5 billion years after the beginning. So our Earth is relatively new. It's only 4.5 billion years old. And I was just talking to Karin about it's hard for us to relate to what a billion is. And Karin sort of recalled that when she was young, that she once had a conversation with God.
So I said, is a penny like $1 billion to you?
I'll play the role of God, and God says, of course, that could be that a penny is like $1 billion to me. And then Karin said,
would you give me a penny?
well, I need to think about that, but if you're willing to wait, if you're patient enough to wait for 1 billion years, Karin, you get $1 billion. So next. So you can do this.
So when hydrogen atoms find themselves in an interaction community called a star, they discover the power to transform themselves into elements that give birth to life. And this is a quote by Brian Swimmy, and he was a cosmetologist.
Right, and you might be interested. He's actually a cosmologist, and you might want to you might check if you go to YouTube and put universe story into the search box. You can get his version similar to my talk today. Because we've tried to cut it down to 20 minutes, but you can get more detail by going to the universe story. Next. Well, we've talked about hydrogen atoms. Now, hydrogen shown here, the sun shown here is really a giant ball of hydrogen, and it's so hot that the electrons are separated from the protons. And so here we're just showing symbolically. Of course, there are billions of protons, but we've just focused on two protons come together and are fused, or the process of fusion by which hydrogen is transformed into helium, which has 2 protons and two neutrons. And this process continues. It doesn't just stop with helium. It continues on to create all the elements. Next slide. Yes, here we have, Ginny, you might just point to hydrogen, which has one proton. And then we have helium with 2. Then you might point out lithium. Has how many, Karin? 3. And the lithium batteries in our cell phones all have that lithium. And here's some of the important elements for life. Carbon, which has 8 protons.
6.
Oxygen,
6.
which
Carbon has 6.
Excuse me, has, I'm sorry, 6. Karin is correcting me. That's right, I read it wrong. Nitrogen has 7, and our air is like 80% nitrogen, and the oxygen, which is necessary for life, is 8 protons. And we might point to calcium here, which is we need for our teeth and bones. So this just shows how our bodies are basically made of water, which has 2 atoms of hydrogen for each atom of oxygen. Their bodies are mostly water. So the basic elements of life are all fused in the stars. Next. This is shown in a little more detail here. You see the hydrogen fused into helium, then carbon, and the other elements, oxygen, silicon, and iron. So this onion layers of a massive star toward the end of their life, toward the end of the life, the stars collapse and explode in these beautiful supernova. This is basically all the elements of the universe, which are forged in this beautiful cosmic dust. The heaviest elements in the periodic table, such as uranium and lead, are formed by fusion in the higher temperatures of the supernovae. Next. So Karin will.
So new stars are created from the dust of the old one, and this is by gravity pulls the stardust together to form stars, and then the planets that revolve around the stars, like how our Earth revolves around the sun. And so this gas and dust rises, and this is known as the Eagle Nebula. And just like I said, our sun formed by the gravitational attraction of the dust coming together to form stars and then planets, and that's how our galaxies are
That's
formed.
how we came into existence. You might notice this is the Hubble telescope, and you've probably been excited to just compare now. Here's the same nebula in the more high resolution. Next stuff shows the Webb. This is the new. This is the Hubble telescope. This is that same nebula. You can see the higher resolution of the James Webb telescope, which was just launched this year. And there again, you can see the stars being formed by gravity being pulled together. The gravity attracts gravity pulls the non-uniformities in this cosmic duct back together to form stars with planets which rotate about them. That's how our sun and our planets came into being. We were created from the death of a supernova. Next. So Karen's going to tell us how life emerged on life, and remember, it all started about 3.8 billion years ago. That's a long time.
And when it started out with the prokaryote cells, which are simple cells, and they don't have a nucleus.
Hold
Then
it a little closer.
Then when the Cambrian explosion happened, we started to form these eukaryote cells, which are more complex, and they have a nucleus which supports more complex life, like humans and animals. And then it shows here how sunlight forms like the plant cells, and they use photosynthesis to live and survive. And that's how newer life started forming, when we used photosynthesis to produce food and oxygen. And then from there on, we had animals, and then into humans, and eventually our pets.
Right. And I'd like to point out here that the original atmosphere of the Earth was carbon dioxide, and plants convert carbon dioxide into oxygen using sunlight. And so the carbon dioxide converted into enough oxygen, and then we could have these complex multicellular life, which includes us. And there's a graph here that explains this in terms of the next. This is another plot of the same thing going on. Basically, 4.5 billion years ago, the first living cells, these were the prokaryote cells, right, Karin? And then photosynthesis, some of the cells, little tiny single cell plant cells, photoplankton, mostly in our ocean, developed photosynthesis, and you can see they started converting over billions of years. You can see the oxygen level increasing, and it wasn't until oxygen levels got up to around 10% that we started getting complex light. I mean, we larger creatures need more oxygen to get energy. That's the way we get energy, is by oxidizing sugar. And so presently, this is the oxygen level today. Our atmosphere is 20% oxygen. And so carbon dioxide is converted to oxygen by photosynthesis and enable animals to get the energy by oxidizing sugars. Next.
So this is a picture that shows how over the span of 4 billion years, how we came from the prokaryote cells, the simple cells, then as we evolved over time to the more complex cells, and then into animals.
Next. Well, this is how we, our kind of human, we're known as Homo sapiens. Humans, who are sapiens, is knowledgeable. We're supposed to be the most knowledgeable. And we had many ancestors. Homo erectus was among the first of our ancestors that started walking erect. And Jenny, I mean, Karin has just been learning about DNA, and turns out we can trace our heritage by analyzing human DNA. And geneticists have tell us, well, I guess it's well known that every mother passes her mitochondrial DNA onto all her offspring, both male and female. Can you explain what mitochondrial DNA is, Karin?
Well, the mother has 2 X chromosomes, and she passes one of them down to all of her children, whether it's a male, which has an X and a Y, or a female that has 2 X chromosomes as well. And so here we can basically trace our X chromosome, that line, from our mother and then from our grandmother and so on, all the way back to the like last common ancestor, basically. And I think Grandpa was explaining how that was somewhere in Africa. They found
East
the
Africa, some
mitochondrial.
Africa. And it's roughly 200,000 to 300,000 years ago. That's relative. That's a lot less than a billion. So we're still relatively new on Earth. We humans are very new. We've had single cell life for billions of years, but complex life is only in the last 500 million years. Next. Okay, Karen's going to go through life's milestone. We've sort of highlighted it.
So this is like, as Grandpa said, when our world all started with the single celled life 4 billion years ago. So that's 9 zeros. It's a big number. And all of these numbers are rounded. But the first single celled life, the prokaryote cells, were first started around 4 billion years ago. Then when the Cambrian explosion happened and we started to get more complex cooperative cellular life, that was 400,000 years ago. Then the mammals start to replace huge dinosaurs about 40,000 years ago. And then us, the first primates and humans, were only about 4,000 years ago. As we said, we traced the mitochondrial line back to right around 400 million.
400 million. Yeah, 400.
And then the Neanderthal human hunter-gatherers was about 400,000 years ago. And then we started to find cave paintings that prove that Neanderthals exist 40,000 years ago. Then the Homo sapiens, agricultural revolution, and writing was only about 4,000 years ago. Then we started Western scientific revolution and printing 400 years ago. And then we started to discover electronics and satellite communication 40 years ago. And then now, today, we have the internet and Facebook and what most people in our world have. So only about 4 years ago.
Let's say it's a little bit rounded off, maybe, but you get it's a factor of 10 between each of these stages. Next. Okay. Well, before agriculture was invented about 10,000 years ago, we Homo sapiens were hunter-gatherers, and that's symbolized by Adam and Eve in the Garden of Eden. There was no agriculture to our knowledge in the Garden of Eden. They just plucked apples, right, Karin? They just picked apples from the tree when they needed an apple. There's no indication of planting trees. That they just nature provided, basically. But in the 1600s, Bishop Usher calculated from the biblical, this is the biblical genealogy, that the biblical Adam lived about 6,000 years ago. Adam can be translated from the original Hebrew Bible as soil, earth, or cosmic dust. Adam's wife, Eve, means to live, breathe, and give life. Adam and Eve, the biblical humans, can be living humans, living humus, or simply humans. Of course, we get our plant life from the humus, the fertile soil. That's where we get that's the basis of our food chain. Their son Cain was a farmer, his brother Abel, a herdsman, and there was agriculture and animal husbandry in Adam's Tigris and Euphrates valleys, now Iraq. And we inherited our 7-day week from Adam's ancient Mesopotamian civilization, which is now Iraq, in contrast to the Egyptians that had a 10-day week. Have you ever wondered why we have a 7-day week? Well, it all goes back to ancient Mesopotamia, the Babylon, and where Adam and Abraham, remember, migrated out of Ur, which is part of what is now modern Iraq. So that gives our human history in the Bible. Next, here's maybe a graphic description of early agriculture, 10,000 years before the birth of Christ. That's the zero here, and it took how many from 10,000 to around 4,000 for a human population to grow above several million. And in the era of city-states, populations started, and we had great civilizations and more advanced technology. Next. Okay, here's where Adam, can you go back just one? Yeah, this is where Adam, this puts Adam, the biblical human, at about 4,000 years before the birth of Christ. And then, of course, we had the Roman Empire right here. Population went up to what was it? Yeah, around 300 million. And now, of course, our population has exploded quite recently. Next. Well, we are the product of 4 billion years of evolutionary success. So let's act like it. And then these are some of the earlier humans. This was our this would be our nearest relative, the Neanderthals, and we have a little bit of their DNA in our genome. And you can see this would be Homo erectus, and this would be about 4 million years ago. Next. The creative evolutionary process is continuing. It's not stopped. We're part of it. And in searching for truth and beauty, we participate and can participate. Next. So as we're in conclusion, created from stardust, we humans are here to light up the world. Next. So
let's go twinkle. That's cute.